So hi everybody, my name is Rafał. I'm a senior software engineer and team leader at DeepSense.io, and today I will talk to you about Neptune, machine learning platform that we created at DeepSense.io. And first let me start how we got the idea for Neptune. So in DeepSense.io we have our own research team, machine learning team, which provides services in areas of machine learning, deep learning, data science for our customers. And this diagram shows the most common workflow for this kind of projects. So first we got data, we need to reformat this data, we need to clean this data, we need to make it appropriate for our algorithms. Then we create source code for training machine learning or deep learning algorithms. We choose some variation of input data, we set up parameters, and then we check one approach and another approach, which we called experiments. So we create source code, we run experiments, we got results, we check in these results. If results are good enough, then we tinker with this algorithm a little bit, we change parameters, we change input data, run another experiments. And when we are finally happy with the results, we write reports, we move our model to production. And as we learned, this is the most common workflow for data science projects. And as we can see, we need to run a lot of experiments in every project. And in Wales projects, in Wales project in our company, as I know, guys run around 1,000 experiments for this single project. So the problem with that is managing the project itself. And we have three major problems when dealing with, we had three major problems when dealing with this kind of projects. So first problem is monitoring of a running experiment. Training deep learning network can take days, and our first approach to check if this training, if this process is performing as expected, was just printing every relevant information to standard output. So every metric was printed out to standard output. Progress, like which iteration are we currently processing, everything was printed to std out. Very often execution environment was some remote environment. So we need to SSH to some remote environment and process very large files, text files, to find relevant information. And it was a nightmare. The second big problem that we had was tracking progress of the project. So as I mentioned, as we saw in this loop, we need to run a lot of experiments. And to be able to keep track where are we in the project, which approaches are we already checked, and which we still need to check, for every experiment, our team members need to record in Excel files an entry, where the columns were like which algorithm, what are the hyperparameter values, what is the result metric. We need to be able to recreate every experiment in the future, to be able to extend research in the future, and we don't know which experiment will be the best and which one will move to production. So we need to be ready to recreate every experiment. So every team member needed to create a snapshot of source code and put to the common storage and put a link here in such Excel files. And the problem was that these Excel files need to be maintained manually, and people were hating it. And there were missing information there. People were forgetting to put entries about their experiments. We had missing hyperparameter values, missing snapshots of source code, and again, this wasn't acceptable. And the third big problem that we had was infrastructure. In DeepSense.io we're using 3 different pieces of infrastructure. We have our own small data center with our own bare metal servers. We're using infrastructure in cloud, and we're cooperating with NVIDIA, so we have access to their clusters. And these are 3 very different pieces of infrastructure with very different resources available and different privileges given to us. And our data scientists, they don't want to bother about where their code is running. They needed a tool where they can say something like, okay, this is my code, I need GPU and I need TensorFlow. Run it, I don't care where, just give me back results. And then they needed such tool. And they created a tool that addresses 3 of these problems. They called it Zeus. And our company recognized the potential in this project. We rewrote it to make it more stable. And now I'm presenting new Neptune, which is a successor of Zeus. And we're using it currently for over a year in our company for every data science project now. And we're running hundreds of experiments every week on Neptune. And now let me show you live demo of Neptune. I will show a sample experiment, which is a handwritten digits recognition problem, a solution for this problem. I'm using logistic regression from TensorFlow on Mini's dataset. This is basically the first tutorial from TensorFlow manual. Okay, so now I will run a Neptune experiment. And we can see how monitoring of a running experiment looked like before Neptune. We had a stream of logs appearing on our screen, and we needed to find some relevant information here in this mess. Now we can go to Neptune Web UI. We can see a job that appeared in running state. We can click on it. And we can see that instead of stream of logs, we have nice dashboard with every metric represented graphically as chart. So we can instantly see if our experiment is performing as expected. If we need detailed information about our metrics, we can go to Channels tab. Channels are mechanism for real-time monitoring. We have 3 types of channels. Numeric channels, which can be used for monitoring metrics. We can customly define any metrics we want. We can send values using channels and see them in real time here in Neptune. We can reorganize these channels to compare them. We can display them side by side. The second type of channel is text channel, which can be used for monitoring logs. And the third type is image channel, which can be used for sending images to our web UI, and this is particularly useful when dealing with image recognition problems. And for example, here, after every batch, I'm sending an image where my algorithm has an image, an example, where the loss function was the highest. So I can see with my eyes where my algorithm is performing not so well and where I need improvements. So channels are the first mechanism for monitoring of a running experiment. The second mechanism is charts. Every numeric channel can be displayed graphically as a chart. We can define charts from the source code, or here from the web UI. We can just click create a new chart, specify a name for that, and select which numeric channels we want to display on this chart. And we just defined a new chart, which is updated live. If we need a closer look for any chart, we can just zoom in. If we need to compare detailed values for charts, we can take snapshots of points and compare them. Very often it's hard to recognize what is the trend on a chart, so we are providing a scroll which helps you with smoothing the chart. This is useful for recognizing the trend, as I mentioned. And to show you another feature for monitoring live experiments, actions, I would like to point you to this chart, alpha, which presents some constant value. And now let's go to Actions tab. Actions are registered function. In your code you can register functions that you are able to run during the experiment execution from the web UI. So I defined a function change alpha, which changes this parameter. So now I can specify a new value for alpha, click run, and we can see in charts tab that alpha indeed changed. And actions are especially useful for example, changing learning rate when we're training our models, or for saving our models. We can define a function save model, and anytime we want, by just hitting this action, we can save our model. So this is for these use cases. So to sum up, we moved from monitoring logs using some external grabs or other tools for browsing logs to nice web UI with channels, with charts, with actions. So this is how we're dealing with the first problem. Now let me show you how we're dealing with the second problem, so keeping track of the project. So I show you the example of an Excel file, and now let me show you the main view of Neptune, experiment list, which shows every experiment executed in Neptune. Neptune records for every experiment, records name, owner, description, when experiment was created. For every experiment, user can define custom tags to add some additional meaning, to mark somehow these experiments. So for example, in our team we're using tags to specify which algorithm are we using, if this algorithm is using GPU or CPU, but we can attach any tags we like. We can filter our experiments, so for example, let me filter only experiments that are relevant to my project. I can save my filters. I already have prepared such filters for my project, so I can delete this filter. And I'll already show you two applications of numeric channels, so we can see them, see exact values. In Channels tab we can see charts, but every numeric channel can also be displayed here as a column in this table. We can go to show hide columns, and for example, I want to compare my experiment using accuracy. So I select accuracy channel, and this channel appeared here as an additional column in this table. So now I can compare experiments in my project using metric that I customly defined. I can sort experiment using this metric. For example, I can see that one of my colleagues has a lot better metric value than I am. So I can see what tags he attached. So I can see that he attached convnet tag, so I can assume that he's using convolutional network, but I don't have to guess. I can go to his experiment and see how the training process performed for him. So I can see exactly which channels he defined, what are the charts for his experiment. But the most important thing is that I can scroll down and I have exact source location for this experiment. Neptune automatically takes a snapshot of source code for every experiment and saves it on a common storage that can be defined. So I have exact source code that was used for this experiment. I can go to parameters tab, where every parameter value is recorded for this experiment. Every parameter value that was used for this experiment is recorded and displayed here. So I have parameter values, I have exactly the same source code that was used for this experiment. When I go back to dashboard, I even get the command that I need to run to recreate this experiment. So we're moving from Excel files that were manually maintained to again nice web UI where everything is recorded automatically, where we're not losing necessary and crucial informations. And now let me tell you how we're addressing the third problem. So infrastructure. So we're addressing this problem with a simple queuing mechanism. Instead of run, I can use Neptune enqueue command. And we can see that a new job appeared in the queued state. And what does it mean? What I did, I added a new job, new experiment from my local laptop to the Neptune queue. Neptune took a snapshot of the source code and put it in a common storage, recorded all necessary job metadata, and saved it on Neptune server. Now I can log into any remote infrastructure and using simple Neptune exec commands execute this experiment. And in our company, we're using that in a way that we have very simple scripts that are executing 3 Neptune commands in the infinite loop. List all experiments in queued state, take first, execute it, and that's it. And our data scientists, all that they need to do now is just they're working on their laptops, they're adding jobs to the queue, and the simple scripts are taking jobs from the queue and executing them on the remote infrastructure. So this is how we are addressing the third problem. Okay, so I showed you the most interesting features of Neptune. Now let me tell you a little about how to integrate your existing code with Neptune. So I want to emphasize that Neptune is not another machine learning library. We're not providing any machine learning algorithms. We are managing tools and monitoring platform. Neptune is not tied to any framework or any programming language. We're exposing REST API, so you can connect with your favorite language and you can use it with your favorite machine learning frameworks. In our data science team using it with TensorFlow, with Tiano, with Keras, with Lasagna. So with all of this scikit-learn, with all of these popular frameworks, we're completely platform and language agnostic. But you don't have to use raw REST API. We're providing high-level client library for Python, so for the most popular language among data scientists. In the next release, we will provide also client library for R, and in the future for Java. And in Python, integrating with Neptune looks like that. We're just importing Neptune from DeepSense package, we're creating context object, and using job from this context object, we can define channels, we can define charts, we can send values to channels. And Neptune currently is in early access phase. You can apply for an early access. You can try it out yourself, how it fits your need. You can go to our website and fill the form and get an early access to Neptune yourself. You will get support from our engineering team. You will have impact on the next features that we will work in the future. So I encourage you to go to our website and sign up for an early access. And I would like to also pass this printed out forms if you would like to fill it out to join this early access program. And that's it that I have prepared for today. And do you have any questions?
Any questions regarding Neptune? Not yet. Nope. I'm joining our after party.
No, unfortunately I can't.
Unfortunately not. No. Okay, probably we can contact you through the DeepSense website or something like that.
Sure, okay. You can contact me.
So if you have any questions about Neptune, you can ask Rafał. You can also fill in the form. And if you don't have any questions right now, one more.
Okay, when you will be ready to get access from Scala language?
For Scala language, so I think I'm sure in the next release we will release support for R and Java. So basically, you can import in Scala. You will import Java library and use it through like that.
Okay, it will be when roughly?
It will be beginning of February.
So a month.
Yeah.
And the last one?
Sure.
Can I use 2 or 3 frameworks in a one time or not?
Sure, you can use it. So basically, you can do whatever you want if in your code. We're just giving you tools for monitoring, for reporting your process. So you have channels, you have charts, but you can send anything you like there. You can use any framework, any library you like.
Do you plan to open source it?
I'm not sure about it. I think this is still discussed.
Okay. Okay, so thanks so much.